Hi, this is Servi aka 31.1 and I would like to welcome you again to our new channel, No Problem Only Solution. And for those who are new to our channel, don't forget to hit the subscribe button as well as the notification bell so that you will get notified whenever we have video content that we'll be uploading in the future. Also, don't forget to leave a message in our comment section so that I could have some time to read them and I could decide which video content I'll be creating in the future. This is a one big time help for everybody as you shape your future on becoming a professional teacher. Thank you very much and see you soon in the coming video. Hello everyone, and we will continue our basic ideas or the prerequisite ideas that you should have before the applications of the derivative. And this time we'll be talking about the minimum and the maximum of a function. Okay, so we will start first with the idea that f of x has a maximum. Okay, f of x has a maximum at x equal to c if f of c is greater than or equal to f of x. This is the idea on how we can say that a function has a maximum. I will illustrate this one in the x and y coordinate system. For example, we have here a function, let's say a parabola which opens downwards. And obviously at this point, this is the highest point of the graph. And here we can say that this one is the maximum. Okay, very obvious, that is the maximum. But this point here represents a value coming from the x-axis, and let me say, or we will assume that that value from the x-axis is c. If this is c, of course its corresponding ordinate coming from the y-axis is the one that we call f of c. And all of the other values here before point c are called x, and other values after c are also called x, and all other values here are called y from the y-axis. That's why here in the definition it says f of x has a maximum at x equals c if f of c is greater than or equal f of x. So in other words, f of c here is the highest point among all other f of x, and point c here is the point that represents the abscissa on this point, which is the maximum. That is the illustration of the maximum. Okay, just remember that if a function has a maximum, it means that it has a highest point. Okay, the other idea is about minimum. Let's say f of x has a minimum. When I say minimum, this is the smallest or the lowest value. Okay, at x equals c if f of c is lesser than or equal to f of x. A while ago, we illustrated a maximum by having this inequality greater than or equal to. But when we are talking of a minimum, we will have this inequality lesser than or equal to. For example, in a Cartesian plane, if we have a graph which is a parabola that opens upward, you will easily identify this point here as the lowest point, and that lowest point is the one that we call the minimum or the minimum. Okay, but this point, like the previous example, came from a value from the x-axis, and that point is what we call the c, and its corresponding ordinate from the y-axis is the one that we call f of c, of course. And all other values here are x, and all other values here are f of x and f of x. But here in the illustration and in the graph, this is the lowest portion of our function. Therefore, this is the one that we call as the minimum. Just remember, the lowest point in the graph of a function represents the minimum, but the highest point represents the maximum. Okay? Some functions do not have maximum and minimum. Okay? In what case that we can say that a function does not have a maximum and minimum? So, this is a special note. Some functions, okay, do not have a maximum and a minimum. I will write here max for maximum and min for minimum. For example, our function is an increasing line. This one. Where is the maximum and where is the minimum? Obviously, there is no max or no maximum and no minimum. Okay? So, this is an example in which we can say that there is no maximum and there is no minimum, because this is a line and it will extend infinitely downwards and upward. Okay, so don't forget that there are some exist of functions in which it has no maximum and it has no minimum. Okay, and also there are some other functions in which there exists a maximum and a minimum. So if previously we have functions that do not have a maximum and a minimum, this time we can say that some functions, okay, some functions have maximum, both maximum and minimum. An example of that is this one. The graph that looks like this one, in the future you will encounter graphs like this. Okay? Where is the minimum? Clearly, this lowest point here, the lowest point of the graph is here, and this one will represent the minimum, and this is the highest part, and this will represent the maximum. Okay, you see this function, let's say y equals f of x, both contains the minimum and the maximum. So in other words, in any function, there are four cases that is possible to happen. The first one, function may have a maximum. Okay. The second one, a function may have a minimum. The third one, a function may some functions do not have a maximum nor a minimum. And the fourth one, some functions may have a maximum and a minimum. Okay, so far those are the different ideas that you should remember when you are talking about the maximum point and the minimum point of a particular function. So far so good. I think we are very ready now to have the applications of the derivative. Thank you very much and see you soon in the next video.